Okay, so we are now going to look at the opposite, let's say, of incremental algorithm design, which is decremental design. So as the name suggests, there's something going to be decreasing at every step, and to be precise, it is the input itself. So in your incremental design, you took the smallest input size, you solved the problem, and then you kept increasing the input size at every iteration. So you're going to do the exact opposite here. In your first step, you will take the entire bunch of inputs given to you, and then by elimination, you will keep removing inputs one after the other until you are left with the final solution. So it is much like your MCQ questions where you use elimination. If you're not sure of the answer, you try to think of what cannot be the answer. So you're like, it cannot be C and D, it's either A or B, and then you work out something and you realize no, it cannot be A either. So you've eliminated 3 options to arrive at B, which is the right option. So that's exactly what decremental design is all about. So algorithms in which only deletions of input elements are allowed. So you initialize everything in an appropriate data structure, and then you keep eliminating at each point. So a classic example of that is this problem called the celebrity problem. So you have a room with n people, and one of those people can be called a celebrity if everyone in the room knows him or her, but he or she does not know anyone. So again, it's important to note that in any given room, the minimum number of celebrities you can have is 0. So if every person knows at least one other person, then nobody is a celebrity, because a celebrity is someone who does not know anyone. He himself does not know anyone. So if everyone knows at least one other person, then there's no celebrity. And the maximum number of celebrities you can have in one room is 1. Because if there are 2 people, X and Y, and let's say both are celebrities, then X should not know anyone because he's a celebrity. So X does not know Y, and which means there is someone in the room who does not know Y, so Y cannot be a celebrity. So the point being, in a room of n people, there can be at most 1 celebrity, at least 0. So I will repeat the problem definition and what I just said. You have a room with n people, and you call a person a celebrity if everybody in the room knows that person, but that person does not know anybody else. So your inputs will be, they'll give you the number of people and they'll tell you who knows whom. So let's say there are 4 of us in this room, and all 3 of you know me, but I don't know any of you, then I would be called a celebrity. So that is how the problem is defined. So you have to find if there is a celebrity in the room, and if yes, who that celebrity is. That's the question. Now, before we go into the solution, a couple of things which you need to understand clearly. Given a room with n celebrities, what is the minimum and maximum number of celebrities you can have? So the minimum is 0. So there are 4 of us here speaking right now, and all of us know each other. So nobody is a celebrity according to this problem's definition of what a celebrity is. So the minimum, of course, is 0, and it cannot go into a negative -1, -2. So minimum is 0. Now, what is the maximum number of celebrities in any given room? It is 1. So if you have a room with n people, whatever the value of n may be, you can have at most 1 celebrity, no more than that. So I'll give you a quick proof as to why. So let's say there is this room with n people, and 2 people, X and Y, are both celebrities. Now X is a celebrity, which means by definition he or she does not know anyone else in the room, and Y is also in the same room. So X does not know Y, because that is how celebrity has been defined. Celebrity is someone who does not know anyone, but everyone knows him. So if I'm saying X is a celebrity, then X does not know anyone in the room. Y also being one of the people in that room, X does not know Y. But I'm saying Y is a celebrity, meaning everyone in the room should know Y. If you know that X is not acquainted with Y, then Y cannot be a celebrity. So we assumed both X and Y are celebrities, but we now arrive at a contradiction. So the point being, in a room with n people, whatever the value of n may be, you can have at least 0 and at most n celebrities. So that was context about the celebrity problem. Now we will actually go into the decremental design part of it. But before that, we'll do the brute force way of finding out who the celebrity in the room is. So you have 6 people, 1, 2, 3, 4, 5, 6 represent the people, and this matrix tells you who knows whom. So we assume that a person does not know himself or herself. So 1, 1, 2, 2, 3, 3, etc. are 0, and that does not count. So I do not have to know myself or not know myself to be defined as a celebrity. So my being called a celebrity only depends on my knowing or not knowing other people, and other people knowing or not knowing me. So the self loops are going to be ignored. Now if there's a 1 in the place of 1, 2, it means person 1 knows person 2. So this one, for example, indicates that person 2 knows person 5. The person on the row is acquainted with the person on the column. And this 0 indicates that person number 4 is not acquainted with person number 2, and so on. So this is the initial data structure given to us. We know there are 6 people. We know who knows whom and who doesn't know whom. So the brute force way of finding out who is a celebrity is, for every individual, you check the row and the column. So the row ideally should be full of zeros, and the column should be full of ones for that person to qualify as a celebrity. So if you take P4 here, P4 does not know anyone, but everyone knows P4. P1 knows P4, P2 knows P4, P3 knows P4. P4 is a self loop which we will neglect. P5 knows P4, P6 knows P4. So P4 is the celebrity in this room. So brute force technique is, for every person, you start with P1, you work your way down to P2, P3 up to P6. For every person, you will check their corresponding row and column. That row should be full of zeros and column should be full of ones for that person to qualify as a celebrity. That is the brute force technique, which will obviously result in a time and space complexity of order n squared, where n is the number of people you have. Now we will see if we can do better using the decremental design technique. So this is the algorithm for brute force, this time and space complexity n squared. Now decremental design la vande, you start with a person. If I knows someone, person I knows someone, then I is not a celebrity. So when you take that matrix and you start exploring that row, we found that the row should have all zeros in order for that person to qualify as a celebrity. So if you encounter a 1 somewhere along that row, then stop exploring that person right away. Eliminate that person from the set of possibilities and go to the next. That is what decremental design is all about. So same set of people, same matrix. How decremental design would work now? Let's say I'm starting with P1 and checking that row. Self loop is ignored, of course. P1, P2 is a 1, meaning P1 knows P2. So P1 is not a celebrity. I will ignore P1 and I will go to P2. P2 does not know P1. So far so good. Self loop ignored. P2 knows P3. So this person P2 also cannot be a celebrity. So you eliminate P2 and you go to P3. Again you check, these 3 are zeros, so far so good. P3 knows P4. So P3 cannot be a celebrity. Eliminate P3, you go to P4. You check, the row is full of zeros, which is very good. So you check the column is full of ones except the self loop, of course. So P4 is the celebrity we were looking for. So you found the answer, you stop. Now you might tell me this is the same thing we were doing, P1, P2, P3, the same order we went even during brute force. But there are 2 things to remember. Brute force la, even when you find a 1 here, you do not stop. You explore this entire row and this entire column for every person. So the number of comparisons is much larger in the brute force technique. First point. Second point, in this example, because the matrix looks like this, the order in which we explored happens to be the same for brute force and for decremental design. But suppose these 2 elements were zeros. Imagine for a second these 2 were zeros. So I am starting with P1, self loop ignore, this is a 0, good, this is a 0, good. I come here, this is a 1, meaning P1 knows P4. So P1 cannot be a celebrity. So directly I will jump to P4 I see that this is full of zeros, the column is full of ones. So in the second person I'm checking itself happens to be the celebrity, Anamari. So the point I'm trying to drive home being, in decremental design, if you are lucky enough, you can quickly eliminate the wrong options and end up with the correct answer. And even though your overall time complexity is going to be n squared, space complexity is also going to be n squared, even in decremental design, the actual number of comparison operations or checking operations or search or traversal, whatever, the number of operations you make will be much less in decremental design compared to your brute force technique, which is why this is in some situations an efficient method.